Number 13. The volume of an open box with a square of base of side x is 810. For the x equals to 9, they want the area of the base and the height of the box. Okay, the area of the base, so the area of the base, you just look at the base, yeah. So this here is the base, okay, and they told us that the sides are all 9, okay. So the area of the base here would just be 9 times 9, length times width, so it's going to be 81. Now the height of the box, okay, the volume of this box is going to be equals to the side squared times height. Yeah, that's the formula for the volume of a box, side squared times height. And they gave us the side already, is 9, so 9 squared times height equals to what? 810. So they told us that. So now that means 81h equals to 810, so h equals to 10. For this question, we've had it before. This you need to make the table, so the first thing we're going to do is derive. So the y prime is 3x squared minus 6x, and now you equate this to 0, and you put it on your calculator. You get x is 0 and x is 2. Okay, so we can now make the table. We put in our values, make sure they're in order. So 0, then 2. And you test a value that's less than 0, I'll put minus 10. A value in between, I'll put 1. A value greater, so 10. If you put minus 10, you take this, put it in our derivative equation. You get a positive number, okay? With 1, you get a negative number, and with 10, you get a positive number. So you could draw our arrows, it goes up, down, then up. Okay, so now we know that this point is a max, and this point here is the minimum. Yeah, so they're saying here a local maximum at x is 0, and they want here a local minimum at x is 2. But for the x is 0 point, they're asking for the value there. The value there just means that they want y. So you take the 0 and put it back in the original equation. So you put it here, minus 3 0 squared plus 13. Plus 13, this is equals to 13. Bas. Okay, here we have a cone, and they gave us the radius plus height is 12. They want the maximum volume is attained at what? Now when they want the maximum volume, minimum volume, this is optimization. We just took this. Okay, so the optimization, you need to derive, then equate to 0. Okay, but to derive, we need to have like only one unknown, right? Because right now they want us to optimize the volume, so we have to derive the volume. The volume of the cone is 1 over 3 pi r squared times the height. Okay, we can't derive this because there's two unknowns, so we need to get rid of one of them. It's easier to get rid of the height, so we could come back here and say that the height is equals to 12 minus r. Yeah, we got that from here. So we come back, and then we could substitute 1 over 3 pi r squared into 12 minus r. Okay, so this is equals to, distribute here, you get 4 pi r squared, and distribute into the r, it's minus 1 over 3 pi r cubed. Okay, so now we have the formula we could work with. We need to derive this. Okay, so the volume, we derive it, you get 8 pi r minus pi r squared. So now this is our derived formula. You equate this to 0, put this on the calculator, you get r is equals to 0 and r is equals to 8. Okay, so now which one of these do we choose? Well, think about it. It doesn't really make sense if we have the radius of 0, right? There's no shape with a radius of 0, so we're just going to ignore this value and take r as 8. Yes. And they want the height also. Okay, come back. So the height here is equals to 12. Substitute our radius, minus 8 equals to 4. Bas. And now they want 3 times the volume. Okay, we come back. The formula for the volume was 1 over 3 pi r squared times height. Yeah, this was our volume. So now that we have the radius and the height, let's just substitute. So it's 1 over 3 pi, the radius is 8 squared times our height was 4. This gives you 256 pi over 3. Yeah, but here they're asking for 3 times the volume. Okay, so you're just going to multiply this by 3. It cancels out here. So your final answer is 256 pi, and they already wrote pi, so you just write 256. This question is similar to the one we solved, I think was number 7. So here we have a paper that measures, it's 21 by 8. Yeah, and they cut from each corner a piece that is x length and x height. So this is x, this is x, this is x. So now our shape looks more like this. Yeah, so that means the volume of this is just going to be the base, right? The volume of a box is going to be the base times the height. Okay, the base for this part here is 8 minus 2x. So, and the base for this part is 21 minus 2x, because we removed x from here, x from here. Same thing with the 8. Okay, so these two multiplied together give you the base. So you could just write that down here. 21 minus 2x into 8 minus 2x. Now times the height. The height, I told you, like, if you could visualize it, that's great. I'm gonna like just kind of try to draw it for you here so you could understand. Okay, we have like the paper, we folded it up, we got this box, yeah? So this here, this is the 21 minus 2x, and this is the 8 minus 2x. Okay, because like these parts, these x's here, so these parts, these are the ones that got folded up. Okay, so if you think about it, that means this is the x, this is the height. Yeah, so that means our x is the height, so we just multiply, this is the base, and that means multiply by the height, which is x. Put x, and then you start distributing. Multiply these two together, you get 168 minus 42x minus 16x plus 4x squared, all of this times x. So your final answer should be 4x cubed minus 58x squared plus 168x. This is our final answer, okay? So you take the parts that they want 58 and 168. You write those down. Bas. Number 17, they want the inflection point. And remember, the inflection point was y prime prime. So we're just going to derive once. F prime of x is 12x squared. And f prime prime of x is 36x. No, my bad. It's 24x. Okay? Because 12 times 2 is 24. So 24x, the inflection point is f prime prime when it's equals to 0. So just equate this to 0, so you get x is 0. This question is the same again. We have the cardboard, piece of cardboard is 30 and 30. They cut off these parts. So now each one of these parts is 30 minus 2x. 30 minus 2x. It's the same thing. Okay, so now our shape looks like this. each of these is x, yeah? Okay, so let's see, they want the volume of the box. Okay, so the volume again is the base times the height. The base would be these two multiplied, so it's 30 minus 2x squared, and the height, remember we said it was x, so multiplied by x. You simplify this, it's like a perfect squared, a squared minus plus 2ab plus b squared is that one. So you get it's 900 minus 120x plus 4x squared, this times x. So you distribute that, you get, I'm just gonna write it in order. You get 4x cubed minus 120x squared plus 900x. Okay, so this is now our volume. And remember, we're optimizing and they want the maximum, so we derive, then equate to 0. So if we derive this, we should get 12x squared minus 240x plus 900. Okay, so that's the derivative. Now we could, we're trying to like factor it. So you could just put this on the calculator and you get x is equal to 5 and x is equals to 15. But remember, before we said that the x has to be less than half of the side. They said here that the side is 30, right? So that means x needs to be less than 15. Okay, this here is x equals to 15, so we can't take this. So we'll take x is 5. Okay? So that's just what they want. Asking for the maximum volume is when x is 5. Number 19, they give you a function, and part A, they're asking for the value of this when x is 0, and gradient when x is 0. So I'm just going to derive it once here. So g prime is going to be chain rule, so 4 into x squared minus 2x minus 15 times the derivative of what's inside, so multiplied by 2x minus 2. Okay, so that's our derivative. If you substitute x is 0 into this, you could put it in, get 4 to 0 squared minus 2 times 0 minus 15 multiplied by 2 into 0 minus 2. You get, wait 1 second. Here I forgot to put the power. Yeah, because this 4 we subtract 1 becomes 3. So yeah, just don't forget to put the power like that. So after you do this, you get 27,000. So that's the answer for part A. Now for part B, we're just going to take our derivative again, which I'll rewrite here. It was 4 times x squared minus 2x minus 15 to the power of 3 multiplied by 2x minus 2. Okay, this is our derivative. And to solve like the roots for this, just take each of these parts and solve for them alone. So you could do each of these on the calculator or just do them manually. But if you put this on the calculator, you get x is 5 and x is minus 3. And for this one, you get x is 1. Okay, so that means we have 3 points for x. So it just has 3 stationary points. Now part C, the coordinates of the points local minimum are this and this. For the local maximum are this and that. Now they're asking for local minimum, local maximum, so just do the table. So do this, that, okay. We got the 3 values, just make sure you put them in order. So it's minus 3, I got 1, and I got 5, yeah. So if you just test a point here, so minus 10 for example, here you could test minus 2, here you could test 3, here you could test 100. It doesn't matter what these numbers are, yeah. Just make sure that like they're in between the numbers. Okay, So this here you get negative, here you get positive, here you get negative, here you get positive. Remember, all we're doing is just taking these numbers and putting it into our derivative. Okay, so here draw arrows, goes down, then up, then down, then up. So this is a minimum, this is a maximum, here it's a minimum, and that's it. Okay, so there's two minimum points. It's when x is -3 and when x is 5, and the maximum point is when x is 1. Here. Now number 20. They give you a function and they want the local minimum and maximum. So for this, just do the table again. So this, just do the table again. So we need to derive first. So 6x squared plus 12x minus 48. Okay, so now we'll do the table. X, y prime, y. Okay, but first we equate this to 0, and you get the roots are x is -4 and x is 2. Okay, so we put those here, -4 and 2. Now test values, this could be -10, here could be 0, here could be 10, it doesn't matter. Okay, take each of these, put them in the derivative, substitute, you get here positive, here you get negative, here you get positive. So it's going up, then down, then up. Okay, so here we have our maximum and here we have our minimum. Right, this is max and this here is minimum. So they want local minimum is when x is 2 and the local maximum is when x is -4. Now part B, when they're asking you about concave, it means you need to do the you need to take y prime prime and put it to 0. Okay, so we got y prime was 6x squared plus 12x minus 48. That's y prime, yeah, we got it from here. So that means y prime prime is 12x plus 12. You put this equals to 0, so it's 12x equals to -12, so x is -1. Okay, so just substitute -1, -1, that's part of it. Okay, now to know if it's greater than or less than, you do the same table. Okay, so x into y prime prime and then y. So we only got one value for x, which was -1. So this gives us 0. So we could test here -100, for example, here 100. Here, if you put this, take this -100. If you put it into our y prime prime, you get a negative number, and here with 100 you get a positive number. This means it's going down, and here it's going up. Okay, so this means that it's decreasing for when x is less than -1 and increasing for when x is greater than -1. Yeah, because here it's just going up, here it's going down. Yes. So you come here, it's concave up, means that it's increasing. When is it increasing? We said when x is greater than. And concave down when x is less.